Alright, so today we're going to look at long division of polynomials. Again, something you've done before. You're going to find that that's a common phrase that I say over and over this semester because you've done this all before. Anyway, so you may remember long division of polynomials. It's very similar to long division of numbers, which you probably did not enjoy when you learned. And maybe that's the same with long division of polynomials. The nice thing about it, though, is it's a process that once you get the process down, it's really not that challenging, it's just kind of tedious. And yes, you're asking yourself, can't I just use a calculator for this? When am I ever going to have to use this or know this? And that's a great question, but no, you cannot use a calculator. Although, this is a great little picture. Look at the little baby, a little adorable little girl. Oh yeah. Anyway. So no, you can't use a calculator because it's polynomials. Yes, this will actually be useful when you take calculus. So you want to know it. Maybe you don't. I do. Divide by hand. So we're going to practice long division. So I want you to take a minute and see if you remember how to do long division of numbers. So pause the video and try to divide this. Unpause when you are ready to check your work or when you are stuck. No, do not use a calculator. Okay, so you should have ended up with 3,134 plus 3/17. Let's talk about this a little bit. First of all, some definitions. Again, this stuff is on your packet. Look at it. Divisor, that's 17. That is what we are dividing by. 53,281, that is the dividend. That's what we're dividing. 3,134, that's the quotient. So that's the result of division. And then the 3, that's the remainder. So how do we go through this process if you don't remember? Well, first, we take the value here, 5. Try to do 5 divided by 17. 5 doesn't divide by 17. So then we take 53. 53 divided by 17 is 3. So I write 3 up here. Now I multiply. 3 times 17 is 51. So I write that below. Now I subtract. 53 minus 51 is 2. Now the process starts again. So 2 divided by 17. Well, 2 does not divide by 17, so I bring down the other 2. 22 divided by 17 is 1. 1 times 17 is 17. Now I subtract. I get 5. 5 does not divide by 17, so I bring the 8 down. 58 divided by 17 is 3. 3 times 17 is 51. Subtract. 58 minus 51 is 7. 7 does not divide by 17, so I bring down the 1. 71 divided by 17 is 4. 4 times 17 is 68. Now I subtract, and I get 3. I can't bring anything else down, so this is my remainder because 3 does not divide by 17. So I write my answer as 3,134 plus 3/17. I do not write remainder 3. We are big children now. We use plus 3/17. Questions on that? Okay, good. So the process for long division, you divide, then you multiply, then you subtract, and then you repeat. It's just like washing your hair. Okay, find the zeros of this polynomial. How do we find zeros? Alright, fine, I'll tell you. You set it equal to 0, remember? Yes, you do. Good, we just did this. So x squared minus 5x plus 6. And this factors. I get x minus 3 times x minus 2. So I get x equals 3 and x equals 2. Great, that's not new. Why are we doing this with long division? Good question. Watch this teaching technique. I'm going to start with something you know, and then I'm going to build into something new. It's magic. So now I want you to divide x squared minus 5x plus 6 over x minus 2. There are many ways in which you can do this. I'm going to pause the video and let you see if you can remember how to do this, and then I'm going to show you 2 different ways right now, and then we'll learn a third later on. So pause the video, see if you can divide this. Okay, so you should have ended up with an answer of x minus 3, and this is how I expected you to do the problem. Maybe you did long division, but we'll talk about that. So I know that this factors. We just did that on the previous problem. So I know it factors into x minus 3 times x minus 2. Since this is multiplication, I can cancel the x minus 2's and I'm left with x minus 3. Pretty simple, right? I could have also used long division. It's way more work. Why would I do that? Good question. We'll talk about that. But let's first talk about the process of long division. So we set it up. Here's the divisor. Here is the dividend. I draw my little division bar. I take the first term in the dividend and I divide it by the first term in the divisor. You are always dividing by the first term in the divisor. So we divide, multiply, subtract, and then repeat. That's the process. Every time with the division step, you're only dividing by the first term in the divisor. Okay, so what is x squared divided by x? It's x. That was division. Now multiply. For multiplication, you multiply by every term in the divisor. So x times x is x squared. X times negative 2 is negative 2x. Now I subtract. So when I subtract, this becomes a minus. That actually became a plus because minus a negative is a plus. This becomes 0. If you've done this correctly, one column should always go to 0. Negative 5x plus 2x is negative 3x, and then I brought down the plus 6. That was subtraction, so now I repeat. Negative 3x divided by x is negative 3. So again, you take the first term that you have here, divide it by the first term in the divisor. Negative 3x divided by x is negative 3. Now I multiply. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Now I subtract, so this became a positive, that becomes a negative, and I get 0. So I have no remainder because I knew this should divide into just x minus 3. So again, the point of this, why did I do long division here? Not because I like to do more work, but because there are going to be problems, which we'll see in the next example, where we have to do long division. And so we need to know the process. So I wanted to show you the process with something that you already know how to do. Bam. Teaching technique 101. Okay, so we're going to do long division here. Set this up. What did I do here? Notice I put in a 0x. You have to put in a placeholder for every degree term between the highest degree and the constant whenever you're doing long division. It might not be important, but it might, and you never know until you actually do the division. Okay, so now we start. X cubed divided by x squared is x. I like to keep my columns straight, so that's why I wrote x above the x column. You can really write it wherever you want up here. It is important that below the division bar we keep all of the columns straight though. So x cubed divided by x squared is x. Great. Now I multiply. X times x squared is x cubed. X times 2 is 2x. So here it was very important that I had that space. Now I subtract. There's nothing under here, so this is going to come down. So I'm going to get 0. X squared minus 2x, and I'll bring down the minus 3. Now I divide again. X squared divided by x squared. That's going to be 1. Now I multiply. 1 times x squared is x squared. 1 times 2 is 2. Now I subtract, and I end up with negative 2x minus 5. I would try to divide again, but I cannot do negative 2x divided by x squared. So I'm done at this point. So my result will be x plus 1, that's my quotient, plus negative 2x minus 5 over x squared plus 2. and we're done. So my remainder is negative 2x minus 5. I write that as a function, negative 2x minus 5 over x squared plus 2. Also notice that I used plus here, and both of those were negative. That is to avoid mistakes. If I make this a minus, I actually have to make this 2x plus 5 because the negative would have to get distributed to both terms in the numerator. So to avoid that mistake, or if this is confusing with what I'm just saying, always make this a plus and then just keep these signs whatever they're supposed to be. Next one, I want you to try this on your own. Do long division. Set it up, divide, pause, unpause when you're ready to check your work. So go ahead and pause. Okay, so you should end up with x squared plus 3x plus 3 as your quotient, and then plus 10x plus 7 over x squared minus 3. So 10x plus 7 is the remainder. How do we get that? X to the fourth divided by x squared is x squared. X squared times x squared is x to the fourth. X squared times negative 3 is negative 3x squared. I subtract, this becomes 0, this just comes down to 3x cubed, this becomes plus 3x squared, so I get plus 3x squared, bring down the x, bring down the negative 2. Repeat, 3x cubed divided by x squared is 3x. 3x times x squared is 3x cubed. 3x times negative 3 is negative 9x. Now I subtract. This becomes 0, bring down the 3x squared, plus 10x, bring down the negative 2. 3x squared divided by x squared is 3. 3 times x squared is 3x squared. 3 times negative 3 is negative 9. Now I subtract. This becomes 0, bring down the 10x, this becomes a plus 9, so negative 2 plus 9 is positive 7. 10x divided by x squared doesn't work, so I'm done there. This is my remainder. But hopefully you're seeing that, yes, long division of polynomials is a little tedious. However, it's just kind of a repetitive process. You divide, you multiply, you subtract, you repeat. Synthetic division is what we're going to learn in the next video. That's a shortcut, but it really only works in specific scenarios. So this is the end of the long division. Why do we care about these long division of polynomials? It's going to help us find zeros of polynomials, which is going to be important in what we do, obviously in this class, but also in calculus. And let's be honest, everything's just about calculus, right?